with solving differential equation for the first order, second order, right? And then we can solve the differential equation by using Laplace transform. All of those is about differential equation, and that is for ordinary differential equation. So after this, in chapter 5, you are going to find the solution of PDE, partial differential equation. So before proceed with that, you have to know about this Fourier series, because we are going to use this Fourier series in solving partial differential equation, right? So what is Fourier series? Okay. So Fourier series is another series where we can use in terms of transform also. We have Laplace transform. Okay. We also have Fourier transform. We also have Z transform. So these are the fundamental knowledge before you can proceed with that. All right. So in this chapter, we are going to learn about periodic function. Okay. Periodic function, even and odd function, and then Fourier series for periodic function, Fourier series for half-range expansion. Okay, so all of these are quite new for you, so please focus on the topic here. So we are going to have 3 objectives. So at the end of the topic, you will be able to sketch graph of periodic function to determine whether the periodic function is odd or even, and to obtain the Fourier series expansion. Okay, so what is periodic function? All right. So periodic function is given by ft plus t equals to ft. Okay, so now we have a function, right? We have our function. We have our function. And then when it is involved with t, with a period there, it is called a periodic function only if ft plus t equals to ft. So now let's take a look at this example. We have fx equals to cos 2 pi x. All right. Now we want to make sure that this fx is a periodic function. So we have to show that the fx plus t equals to fx. This is your original function. Now this is periodic function where it involves time, period. So fx is cos 2 pi x, then fxt equals to cos 2 pi x plus t. Okay, where by identity, fx plus t here is cos 2 pi x plus 2 pi t, right? So by identity of cos A plus B, we can expand this to what? Anyone? Identity of cos 2 pi cos A plus B. Okay, cos A cos B minus sin A sin B. Right? So now we expand. Now we have cos 2 pi x cos 2 pi t minus sin 2 pi x sin 2 pi t. Okay? So we are going to find what is the value of t so that this fxt equals to this fx. Okay, meaning that in order to get that this cos 2 pi x, you have to make sure this is remain only when this is equals to 1 and this is equals to 0, right? When this value equals to 1 and this equals to 0, then fx plus t equals to cos 2 pi x, where it can be equals to cos 2 pi x of fx there. So we have to make sure that this cos 2 pi t equals to 1 and this sine 2 pi t equals to 0. So solving this, cos 2 pi equals to what? Cos 2 pi equals to 1, right? This is 1, this is t, then t equals to 1. Sine 2 pi equals to 0. So this is 0 equals to 0, no solution. So we have t equals to 1. So now fx plus t equals to cos 2 pi x plus t now is equals to fx, for which this fx is cos 2 pi x. So what we can conclude that fx is a periodic function where t equals to 1. Is that clear?
Doktor,
Yes?
untuk cos 2 pi t dengan sin 2 pi t tu kan kita just assume je ke? Macam cos 2 pi t equals to 1 assume je ke?
Dia bukan assume. In order to remand the function, okay, in order to remand the function, this value must be equals to 1 and this must be equals to 0. So we just can have two equations here and solving these two equations will give you t equals to 1. Okay, so the word is not assume, but you have to identify the value of that cos 2 pi t and sin 2 pi t in order to remand that this cos 2 pi x. So that at the end of the calculation here, fx plus t equals to fx. So this is our conclusion for which this function is a periodic function now. Okay, understand now?
Faham, Doktor. Thank you.
Right. Okay, anyone has question? All of you understand? Okay. Right, so this t equals to 1, we call it as a period or fundamental period. Therefore, fx is a periodic function with a period of 1. Okay, so now let's take a look at example 2. Okay, we have sine 5x. Okay, let me just explain here. We have sine 5x. So now we want to check whether this sine 5x is a periodic function or not. So if yes, find the period. So in order to make sure that this is a periodic function, you have to prove fx plus t equals to fx. Okay, where fx is sine 5x, then fx plus t equals to sine 5x plus t, where it is sine 5x plus 5t in terms of sine a plus b. So by identity, we can expand this to sine 5x cos 5t cos 5x sine 5t. All right, and then we want to remand this sine 5x. So this one should be equals to 1 and this one should be equals to 0. Okay, so when cos 5t equals to 1, okay, when cos 5t equals to 1, we can have 5t is arc cosine of 1, where it can be, here it can be 2 pi, right? Cos 2 pi equals to 1, okay? Or cos 0 equals to 1, right? We have what? Cos, okay? we have cos 2 pi equals to 1. We have cos 0 equals to 1. So 5t equals to 2 pi and 5t equals to 0. And by definition of a periodic function, t cannot be 0. So we cannot take this. Okay, then t equals to 2 pi over 5. Okay, and then this one, sine 5t equals to 0. So sine what equals to 0? We have sine pi equals to 0. We have sine 2 pi equals to 0, right? Sine pi here, sine pi, cos and sine. Sine 0 equals to 0 also, right? Okay, and then, yeah, all right. But you have to make sure that this t must fulfill both cos 5t equals to 1 and sine 5t equals to 0. So we have to choose both value that can fulfill these two expressions. So 2 pi and 0. So 2 pi and 0. But we cannot choose 0. So we take 2 pi here. And then 5t equals to 2 pi. So that's why t equals to 2 pi over 5. Same. Okay. Then 5x is sine 5x here is a periodic function where fxt plus t equals to this, where t equals to 2 pi over 5. Understand or not? Anyone ask question?
Doktor boleh ulang ke cos 5t kenapa dapat 2 pi? Dapat cos 2 pi.
This one?
Ah.
This one? Okay. You can check by using your calculator, but according to the quadrant here, okay, the special angle here, what is the value of cos which will give you 1? So as you can see, here is 1, right? This is cos and sine. Where here we have cos 0. This is the angle 0. Another one, when you reach one circle, so another one is 2 pi, also 1. So cos 2 pi equals to 1, cos 0 equals to 1. Okay, understand or not? So we start at angle 0, okay? We start at angle 0 here. And then we go one full circle to get 2 pi. So for angle equals to 2 pi, also 1. Then we have cos 2 pi equals to 1, cos 0 equals to 1. But t cannot be 0, so we cannot take this. So we just take this. So when cos 2 pi equals to 1, we can compare with cos 5t equals to 1. Right? Cos 5t equals to 1. So cos 2 pi equals to 1. Then 5t equals to 2 pi. T equals to 2 pi over 5. Or you can just cos 5t equals to 1. 5t equals to inverse cos 1. But by calculator, you can obtain only one value, right? But for this one, you have to check. There is two value, but we cannot take 0 because t cannot be 0. So for this case, t equals to 2 pi over 5. Because inverse cos 1 is 2 pi. Okay. And then for this case, sine 5t equals to 0. So what is the value of sine which give you 0? So first we have 0. Sine 0 is 0. And then we have pi. Okay, sine 180 degrees, sine pi. And then we have 2 pi again. So we have pi, 2 pi, and 0. But this selection of value here must fulfill both functions. So the acceptable value is only 2 pi. So that's why for sine 5t, t also equals to 2 pi over 5. This one is t 2 pi over 5. So we can conclude that the period is t equals to 2 pi over 5. All right, clear now?
Yes, doctor. Thank you, doctor.
Okay, so this is how you prove whether that function is a periodic function or not. You have to find the period t there. Okay, and this Fourier series is applied to periodic function. So after this, we can see where can we apply the t there, the period there. Okay, so how can you identify the periodic function? This is how you prove it. Fxt equals to fx. Okay, next, you need to understand the even and odd function. All right. Yes, is it possible to have more than one values of period? Yes. In calculation, yes. But at the end, you need to select the the smallest value. Okay. Let's say for this case. Okay, let's say if you choose pi, means that 5t equals to pi over 5. Okay, but we cannot choose pi. But what if we can choose pi? So when t equals to pi over 5 and t equals to 2 pi over 5, this is the smallest, right? So we need to choose this. But for this case, no, cannot. All right? If we have more than one values of period, we need to choose the smallest one. Okay? Is that clear? All right, good question. Okay, next, even and odd. So the function is even when f negative x is equals to fx. Okay? And the function is odd when f negative x equals to negative fx. Okay, by definition, it is defined by that. Okay, but by graph, by geometrically, even function is symmetric about the y-axis. So this is the example. This is the reflection line, the symmetric line here. When it is symmetric about y-axis, then we call it as even. Okay, and then for odd function, the graph is symmetric about the origin. Okay, where the origin, the symmetric line can be here or here, right? So in even, the symmetric line is here. Okay, if none of 1 and 2 are satisfied, if it is not even and it is not odd, then we call it neither even nor odd. So there are three types of function: even function, odd function, and neither even nor odd function. Okay, so these three will determine what type of Fourier series expansion after this. Okay, so for this example, how can you identify the function they are even or odd? Okay, so for the first one, fx equals to x squared. Oh, sorry. We have the definition of f negative x, both even and odd, right? So you just check. What if you substitute negative x? If you got fx again, then it is even. If you got negative fx, then it is odd. So now for fx equals to x squared. When you substitute negative x, then negative x squared becomes x squared. Then f negative x is fx. So we say that the function is even function. Okay. Second one, hx equals to sine x. When you substitute negative x, then you got sine negative x, where sine negative x here is actually 0 minus x. So in terms of sine A minus B, it can be expanded to sine 0 cos x minus cos 0 sine x, where this is 1. Then you have negative sine x. So h negative x is negative sine x, where it is negative hx. So it is odd. Okay? Then the third one, we have g negative x equals to minus x. We have gx. Okay, and then we substitute negative x, means that negative x to the power of 1 over 3. minus sine negative x. Okay. And negative x to the power of 1 over 3 is still negative x to the power of 1 over 3, right? Because cube root of 9 is, of 8 is 2. And also cube root of negative 8 is negative 2. So this negative remain. Okay. And then negative sine negative x is, by looking at the previous example, sine negative x is negative sine x. So negative. Then we factorize, we got negative gx. So g negative x is negative gx, then it is odd. All right. And then the last one, ft equals to exponent t. When you substitute negative t, you got exponent negative t, where exponent negative t is not negative exponent t, or exponent t is not equals to exponent negative t. So this function is neither even nor odd. Understand or not? The difference between even, odd, and neither. Anyone has question? Okay, this is easy. Next is you have to understand the properties. Okay, the properties of even and odd function. All right. If for addition and subtraction, even plus or minus with even will give you even. Odd plus minus with odd will give you odd. Even plus minus with odd will give you neither. Same function, same even will give you even. Same odd will give you odd. For addition and subtraction, different even or odd will give you neither. Okay, and then for multiplication and division, same even will give you even, same odd will give you even, and different odd or even will give you odd. Okay, so for integral properties, for even function, you know that even function symmetric about y-axis. So instead of integrate from -2 to 2, you just can integrate 1, then just multiply with 2. So you can integrate 1 from 0 to 2, let's say here, from 0 to 2, and then multiply with 2 to get all shaded region area there. So that is for the integral properties for even. And for odd, since it is symmetric about the origin, okay, when you integrate from -L to L, from -L to L, it will give you 0. Why? Because once you have the region here, let's say this is negative a, this is a, then you just can add these two, you get 0. So this is the properties of odd function. All right. It is important to understand the integral properties of even and odd before you can proceed to the next section. Is that clear, everyone? Anyone has question? Okay, no question. All of you understand? Right. So now let's try to understand this Fourier series. Once you understand the periodic function, the even and odd function, now you can understand this Fourier series. Okay, don't worry. It's not as hard as you think. Okay, now, what is Fourier series? So Fourier series is defined by an expansion of a function in a series of sines and cosines. So we have a function. Let's say fx equals to x. So this is just a function. Then this function can be expanded to this series in terms of sine and cosine. So how? Let's try to discuss this. Okay. Okay, now before you can proceed, you can have to take a look at this. This is the definition of Fourier series, where it is an expansion in terms of cos and sine. And we have the constant value of A naught, An, and Bn. So how can we find A naught, An, and Bn? So this is the formula. A naught, An, and Bn. Okay. Where L here equals to T over 2. You know what is T? T is a period from the periodic function earlier. Okay. And then you have to understand when fx, your original fx, is even, okay, then bn equals to 0. No need to find this bn. Only a naught and an. Okay, then bn equals to 0. Right? Hence, your Fourier series, instead of this, when bn equals to 0, now it becomes only up to an only, where you can find a naught and an like this. Okay, because this is even. Now, if x is even, then just use the integral properties for even. Okay, now when fx is an odd function, then a naught and an equals to 0. So instead of full Fourier series like this, now a naught and an is 0, so you just have to find bn. Okay? All right? And then when fx is odd, and you know that sine is odd times odd is even. So by integral properties, bn can use even properties. Okay? So now what we can conclude here is when your function is odd, you have to take a look at this third formula here. When the function is even, then just find a naught and bn here. And when it is neither, only when it is neither, then you need to find all constant a naught, an, and bn. Clear not? Understand or not? Anyone has question? No. Okay. So the most important part is you have to understand your fx is what? Even or odd or neither. Okay. When you know the type of function that you have, then you can decide which formula that you have to use to find the Fourier series. If it is even, then just follow the second formula. When it is odd, then we use the third one. When it is neither, then we use the first one. Okay, so use first, second, or third here to do what? To find Fourier series. Why we have to choose? Because our focus, our aim is to find the Fourier series. But we need to decide which formula so that you don't have to find every constant every time you do it. Okay? So let's try to take a look at this example. Okay, let's try to do this one by one. What is your first step? Okay, first step is you know that this is periodic function. Okay, in order to find the Fourier series, you have to know that this is periodic function. Before this, what we are doing is to prove whether that this is a periodic function, but this is given already. Okay, when you have this kind of information, you know that this function of x is a periodic function where the value of t equals to what? Yes, okay. Because the definition of periodic function is when fx plus t equals to fx. So it is a periodic function when this fx plus t equals to fx. Before this, we can prove, right? But now it is given already. So this information give you that this function is a periodic function by given t equals to 2. And remember, L equals to t over 2. So L equals to 1. As you can see, this is L because the range is from minus L to L. Okay, clear not? So your first step is to identify the value of T and L. Okay, second step, identify that function is even or odd or neither. So how can we identify it is even or neither? Of course, fx equals to negative x. By this example, you know that it is what? Fx equals to negative x is odd. Okay. So basically, you can find f negative x equals to negative x. So f negative x equals to x, which is negative fx, right? Where this is odd. Okay, by definition, okay, we can find the types of function here by plotting a graph. So fx equals to negative x is given by this, right? Okay, from -1 to 1. As you can see, when the symmetrical line is about the origin, and you can see that it is symmetric about the origin. So what can be defined by t? Means that this is a periodic function where it is repeated every t equals to 2. This is the original function from -1 to 1. So when t equals to 2, it is again repeated. When t equals to 2, it is again repeated. Okay, but we have to consider only from -1 to 1. So let's just consider this function. Okay, now you know how to sketch the periodic function, right? Okay, so next, this function is odd. When the function is odd, which formula that we can use? Okay, the third one. So now, by looking at the third formula here, what you have to find is only Bn because a0 and an is 0. So your Fourier series only consists of Bn, where how to find Bn? Bn is 2 over L, integrate from 0 to L fx sine n pi x over L. And your L is what? What is your L? L is 1. Okay, from 0 to L, L is 1. Fx is negative x. Sine n pi x over L, L equals to 1. So substitute everything and you can have this integration. Okay, we have negative, we have 2, so put negative 2 outside as a constant, and we have x sine n pi x. So integrate this by tabular method or integration by part. So you have this. Okay. Let decide u equals to x, du equals to 1 dx, dv equals to sine n pi x, and v equals to negative. So integrate sine n pi x, we get negative cos n pi x over n pi. So substitute here, simplify. Okay, this is negative x cos n pi x over n pi minus integrate negative cos n pi x over n pi. Okay, substitute here, we get up to this. Okay, up to this. Cos n pi can be simplified to negative 1 to the power of n. Because why? Cos 0 is 0, cos pi is minus 1, cos 2 pi is 1. So cos n pi is negative 1 to the power of n. So this cos n pi can be simplified to this. Alright? And then sine n pi. Sine n pi. Sine pi is 0, sine 2 pi is 0, sine 3 pi is 0. So sine n pi is 0. So this is 0. Sine 0 is already 0. Then this is 0. This is 0. So what's left? Negative cos n pi. Negative, negative 1 to the power of n over n pi. Times with minus 2. So minus minus is a positive. So this is your Bn. Okay. Once you got your Bn, then just substitute to the Fourier series here. Okay. Where fx, your Fourier series fx equals to summation, all right, summation Bn is what? Bn is 2 over n pi sine n pi x over L. L is 1. Okay, so this is constant. This is constant. So put constant outside. Okay. So this is how can you obtain the Fourier series for fx equals to negative x. All right. Is there any question? Is it too small? Okay, we start with finding L and T, and then identify the types of graph. No need to memorize. This formula is given. Oh yes, you have to memorize. Sorry, the formula is not given. Where to know sine and pi equals to 0? You have to know it by your own. We can just simplify. You know that sine pi is 0. Sine 2 pi is 0. Sine 3 pi is 0. So from this, you can conclude that sine and pi equals to 0. Okay? Same like cos. Cos 0 is 1 1. Cos pi is minus 1. Cos 2 pi is 1. Then cos and pi is minus 1 to the power of n, where n start with 0. 0 pi, 1 pi, 2 pi. Okay, this is given in your notes, right? Okay. Any question? No question? All of you understand this? Can you see it? Can you see the screen here? Is it too small? No problem, eh? All right. By the way, are you listening? Can you listen to me? I think that I'm just talking alone. Okay, so let's proceed. Okay, now we have here a piecewise function. As you can see, your fx equals to negative x, where the range is from -pi to 0. And fx equals to x for 0, x from 0 to pi. And you know that this is a periodic function where t equals to pi. And when t equals to pi, L equals to pi. As you can see, here is L. Because the range is always from -L to L. From -pi to pi. So next, you have to plot. So for this case, you have to plot to know whether the function is even or odd or neither. So as you can see, function f equals to negative x from -pi to 0. And the function equals to x from 0 to pi. So it is repeated about t equals to pi, then repeated. As you can see from this graph, it is symmetric about y-axis, where this is your reflection line. And when it is symmetric about y-axis, then the function is even. Okay, so now when the function is even, you have to refer which formula? Okay, when the function is even, you have to refer to the second formula here where Bn is 0. So you have to find a naught and An. Is that clear? So now, from the second formula there, right, what you have to find is only A naught and An. Okay, so you have to know that Fourier series that you need to obtain is in terms of fx a naught over 2 plus summation an cos n pi lx. Okay, where a naught is given by 2 over L. L is what? L is pi, right? L is pi. Integrate from 0 to L. L is pi. Fx dx. So now, from 0 to pi, which fx satisfy the range? Negative x or x? Okay, so because we have two functions here, and you need to know which function that you can choose by looking at the range in the integral here. So the integral is from 0 to pi, then it involves only x. So your fx here is x dx. So this is for a naught. Okay, and then for an, again 2 over pi from 0 to pi, also fx is x cos n pi over pi x dx. So we just can integrate cos n x dx. Okay, is that clear? So when you find your a naught and an, just substitute again to your fx to find your Fourier series. Okay, try to find a naught and an then. Try to guess.